Hi everyone, welcome to this video. Today we're going to have a look at what's called kinematics. So kinematics is basically the study of motion of a particle without actually considering the cause of the motion. When we talk about kinematics, there's really three things we look for. What we talk about is displacement, velocity, and acceleration, and they're all linked together, as we'll find out later on. Um, when we talk about displacement, it's usually denoted by x. For velocity, just v, and acceleration is a. So that's what the notation for each of those. Displacement is the position of a particle, specifying both distance and direction. Um, so basically, it's just the position. And displacement's probably one of the most common parts of this. Um, for velocity, v, it measures the rate of change of displacement. So what that's talking about, if we rate of change of the displacement, if our displacement is x, the rate of change, we're talking about the derivative, so it's actually um, the derivative of x. And we're talking about t in terms of time. So I'll just put a note up the top. Okay, when we say t, most of these fall into under time. So how fast are we going? Rate of change of displacement. So how far are we going? So kilometers per hour, or it's our distance over time. Acceleration is the last one, is going to be the average, sorry, the rate of change of velocity. So rate of change for velocity, and essentially it's the same thing as um, the displacement. So the rate of change is going to be dv dt. So for v, we've got dx dt. For a, we've got dv dt. Just as a side note, something to take further, if we know dv dt is a, and actually no, forget about that. That's going to confuse you. So displacement, velocity, acceleration, three things we're looking at. When we look at displacement, commonly used conventions for motion along a horizontal straight line. So we've got either x is greater than 0, x less than 0, or x equal to 0. So this is the talking about how far away from the origin. Okay, if x is greater than 0, it means that the particle is to the right. Oops. Okay, so positive meaning particle is to the right of the origin, and if it's less than 0 or negative, it's going to be the same thing, but we're going to be to the left of origin. If it's equal to 0, it is at the origin. Alright, so what we're talking about is if um, we have x equal minus 10 on a straight line, our origin is here at minus 10 here, so we're sitting to the left of the origin. It's also important to note this distance here at minus 10 is going to be the same as if we looked to the positive of the origin. So it's just talking about are we to the left or to the right? Positioning is what that symbol there, the positive or negative. As x equals 0 means we're sitting at this spot here. Velocity, very similar to acceleration, a a particle moving in a horizontal line. So the sign of the velocity indicates that if it's greater than zero, we're moving. Now we're moving to the right. If it's less than zero or negative, we're moving to the left. And if it's equal to zero, we're not moving or is stationary. Average velocity, slightly different. So it's the rate of change of the displacement measured by the gradient of the chord measuring 2 points on a position time graph. So if we were to graph a function f of x, and it might be um, quadratic, and this is our distance and time. So our distance varies depending on the time. This is our graph, and we want to find the rate of change um, of the displacement. So we're looking at the distance between, it might be 3 and 4. So we'd plot those 2 points and we'd find the distance, find the rate of change of that. So that's essentially what we're doing. So it requires coordinate geometry. We can't use calculus. And to find those, we can just use our straight line average velocity. So the change in displacement, well, it's going to be our y2 take y1. In this case, it's x2 take x1 because that's our y values. Usually we have yx against x, we've got x against t. So instead of x, we're going to have t2 take t1. So that's how we would find the average velocity. Last thing, acceleration. As we said from the first slide, we've got the three kinematic information x, v, and a connecting each other. And as we had a look at before, we find v by finding dx dt, and we find a by finding the derivative of v. So acceleration measures the rate of change of the velocity. Usually we denote that by meters per second squared. Can sometimes be written as ms to the minus 2. It's just notation, whereas velocity usually is meters per second. And for displacement or the distance, usually kilometers or meters. Just going to have a look at worked example 14. So a particle moving in a straight line such that its displacement from the origin at time is modeled by the equation. And I'm just going to copy that. So part A says identify the initial position. So we're talking about displacement in terms of time, t. So t is time. Initial means where are we before we start moving, basically. So we're finding x when our time is basically 0. It's before we start. So we're just using t equals 0. Alright, work that out. We get x is actually minus 12. Just means that we're 12 units to the left of the origin. Just remember that for our negative sign. Part B says obtain the velocity and hence state the initial velocity and describe its initial motion. So the its velocity, if we remember, v is actually the same as dx dt. If we find the derivative of the original function, okay, so our derivative is going to be 2t take 4. So that's our velocity. Hence states initial velocity. So I'll write at time t equals 0 for initial, we get v equals minus 4. So describe its initial velocity. So at t equals 0, our initial velocity is negative, meaning that we are to the left of the origin. So we're moving left of the origin. Okay, v is less than 0, so we're moving to the left. Part C says to what time and position is the particle momentarily at rest? So at rest, we're finding the velocity when v is, or the time when v equals 0, um, meaning that it's stationary. Yeah, so our velocity was 2t take 4, so we're solving that when it's 0. So if you work that out, we get t equals 2. So the position of that is when we find using our x function, we just sub in t equals 2. And if we do that, we'll get 0. So the particle is at the origin. When t is equal to 6. Part D says show the particle is oops, hang on, no, I've missed a bit. Go back. Take 2. So t equals 2. We get 4 take 8 take 12. So x is actually minus 16. So the particle is momentarily at rest after 2 seconds at the position 16 meters to the left of the origin. So part D says show that the particle is at the origin when t equals 6 and calculate the distance it has travelled to reach the origin. So when t equals 6, Okay, we get x equals 0. So the particle is at the origin when t equals 6. The motion of the particle for the first 6 seconds is going to be so we've got our origin. We started at minus 12. That's from part A, when t equals 0. At t equals 2, we found it was minus 16. And then we turn back around and end up back at the origin at t equals 6. So that's describing um, the path that it's taken. So the total distance that we've travelled is the distance between minus 12 and 16, sorry, which is a 4, and then the total distance there, which is 16. So 4 plus 16 gives us 20. So the particle has travelled 20 meters. Calculate the average speed over the first 6 seconds. So average speed if you remember back is distance over time. We found that our total distance was 20 and the time for that was 6. So working that out, it's about 3.5. And we're talking about speed, so it's meters per second. And the last bit was calculate the average velocity over the first 6 seconds. So average velocity is the average rate of displacement. Okay, our first position was at 0 minus 12. That was our initial. Second point we had was at t equals 6 and 0. That's where we end up. So x2 take x1, we get 0 take minus 12 over t2, which was 6, take 0, we get positive 12 over 6, which is 2. Okay, and I'm going to leave it there. So that's it for chapter 13.7. Have a go at the questions. Thanks for watching.